So for u substitution, the first thing you have to do is look for the composite function inside of the integrand. So you look for the composite function, and then you look for, since the composite function is two different functions put together, there's going to be like an outer function and an inner function. And with our first example here, 3x squared times the sine of x cubed, your composite function, which one do you think it is? Is it the 3x squared or is it the sine of x cubed? Yeah, it's the sine of x cubed because there's two functions going on here. The sine of something and something cubed. So there are two things happening there. There's always going to be an outer function and an inner function. And you have to determine what's the outer function and what's the inner function, because the inner function is what we're going to do all the u substitution for. The outer function is going to be the one that we're going to integrate. The inner function is what we're going to replace with a u instead of whatever crazy function of x it is. So now, if I have the sine of x cubed, what's the outer function and what's the inner function? The sine is the outer function. Because basically what's happening with these two, we have a sine of x and x cubed. Those are the two functions that were put together to make the composite function. The one on the outside, if we were to do this, the first thing we'd do is x cubed. The second thing we would do is the sine of whatever that number is. Do you agree with that? That the first thing we would do would be x cubed? Alright, now, whatever we do first, whatever we work through first is going to be what we're going to substitute our u for. So if u is going to be what we do first, what we would do first is x cubed. Now, du, instead of u prime here, I want you to put a du because that's what we're going to replace this. We have a dx there. We need to change it to a du and not a u prime. It's semantics. That's all it is. Now, what's the derivative of u? Because this is, which would be what? 3x squared times dx. Now, this is key. The dx is always key because if we were going to take u, we would go du dx. That would be the derivative of u with respect to x, which is what we've done with every derivative, except for they're separable, which means I can multiply both sides by dx, and I got that here. Now, after we get to this part, I know this is going to become a u. So I'm going to get the sine of u. Do I have everything that makes up the du? Do I have a 3x squared? And do I have a dx? Yeah, so that would become what? The whole thing would become du. So now I've taken a complex integrand here, which just ended up being a function, sine of x cubed. And if I took the derivative of it, it'd be sine of x cubed times the derivative of x cubed, which would be 3x squared. And now I can say, all right, well, what's the derivative of the sine function? Negative cosine of u plus c. And now, never leave stuff in terms of u. U's bad as your final answer. U is what we do all the work with, and then we polish it up for a really nice final answer, put everything back in terms of x. So it's the cosine of x cubed plus c. And then if we wanted to, we could go back and we can take the derivative of that to make sure that that's exactly what we would get. If you take the derivative of x, or negative cosine of x cubed, you'd get the opposite of the negative sine of x cubed times 3x squared. Yes, sir? Where? That's the antiderivative of the sine. Is the negative cosine. We integrated it. We didn't. Yeah, with sines and cosines, it's a little bit weird because the derivative of the sine is the cosine, and the derivative of the cosine is the negative sine. So, if you take the derivative of the sine, you get the other one. If you take the derivative of the cosine, you get the other one. When you integrate it, you get the other one. So, yeah, do you see what we did, though? Oh, no worries. All right, now, there's going to be a time when, first off, we good with this first one? Now, what's the most complicated part of x times the quantity x squared plus 9 to the 5th power? That's your composite function. What's the inside? What would you do first in that composite function? The x squared plus 9, right? You're always going to do what's inside. Yeah. So u in this case is going to be x squared plus 9. Du is going to be equal to what? 2x dx. Now, my next question is, outside of where's my red pen? All right, I know this is going to become u. So I know I'm going to get u to the 5th, but do I have 2x? No, I only have an x. Now, what's the most powerful trick a mathematician has? All right, multiply by 1/2 on the outside. But if I do that, what else do I have to do? Multiply it by 2 on the inside. Because what's 2 times 1/2? 1. So do I change the value of the integral at all by doing that? No. So it's that trick, that multiplying by 1 is the biggest mathematical trick that any of you have. And when you're doing u substitution, this is a big trick. Now, do I have enough? Do I have my 2x? Yes. Do I have my dx? Yes. So I can change that to my du. But what's left over that didn't go away? The 1/2. So be careful not to lose that 1/2. That's got to go with it. So this is going to be equal to 1/2 times, well, what's the integral of u to the 5th? Yeah, u to the 6th power over 6. Oh, plus what? Plus c. Can't forget the plus c. If I take out the 6, 1/2 times 1/6 is 1/12 times. Now, what was my u value? X squared plus 9. That's going to be to the 6th power plus c. And that's your final answer. I did. U is x x cubed du was 3x squared. Because it was the sine, it was basically taking like the sine of x, which we have a rule for. Right. If you have the integral of sine x dx, it's equal to negative cosine x plus c. So we got it to a form that we had a rule with. So if you can get it to a form that we have a property or a rule to integrate it with, that's what you want to do. So we didn't have to do anything with the u that was inside there.
I don't quite understand it. Like where did like in the first problem, where did the 3x from the du go? 3x squared.
I took from u, I took du.
Yes, I understand. Okay, so the u was x to the third, right?
Right.
So then why you found the derivative of that because of the dx in the problem, or because it's an integral?
Because if I had just the sine of x cubed, and I say take the derivative of that,
That's right.
derivative of that's going to be
Negative
cosine of x cubed times 3x squared. Or if I had, even if I had the cosine of x cubed, it would have been negative sine.
So why did it go away then?
Why did what go away?
3x squared.
Because it was the chain rule. Basically what we're trying to do is we're trying to go from f of x to f prime of x and then back to f of x. That's what we're trying to do. And or at least get to something that's really close to f of x. Now, when we take a derivative, if it's a composite function, there's a chain rule. So you're going to get your derivative and then times the chain rule. And then when you get back to this, the chain rule goes away. Because the chain rule isn't there when you start with. The chain rule will go away.
Makes a bit of sense. Right. And then that's why the 2x went away in the current number 2.
Yes, because that would be the chain rule of x squared plus 9. Better?
Yes.
Okay, good. Now, what's the most complex function in the third one? The bottom. And what's the inside of the bottom? What's going to be my u? X cubed plus 3x squared plus 12. And when we took the derivative, basically remember, this is a derivative. What's in here is a derivative. And so this was the function that we took the derivative of. And that was the chain rule. Hold on 1 second. So up here, this has to be my chain rule. And once we integrate it, the chain rule will go away. So I need my du to be equal to, well, what's the derivative of x cubed? 3x squared, and 3x squared is 6x. And then all that times dx. Now, if I look at what I have up here, x squared plus 2x, and I have 3x plus 6, or 3x squared plus 6x. Yeah, you can factor a 3 out, right? And then you get your x squared plus 2x dx. Now, there's my x squared plus 2x, there's my x squared plus 2x, there's my dx. What am I missing? Well, I'm missing a 3 there, and a 1/3 on the outside. Because 1/3 times 3 is 1. Do we change the value of the integral? Nope. So now, I can change this to 1/3 times the integral of all of this up top becomes du. And down here, I just get u to the 6th. Now, which one looks like it's a little bit easier to integrate? The top one, the original one that we had, or this guy right here? This guy. This is just doing a little bit of rewrite here. This is u to the negative 6 du. That's just a power rule, isn't it? Alright, so to integrate this, how do I integrate? Do I subtract 1 or do I add 1? Add 1. So it's going to be u to the negative 5 over negative 5 plus c. Now I'm going to take that negative 5, since it's in the denominator, multiply it to the denominator of 1/3, and get negative 1/15 times, now u to the negative 5th is 1 over u to the 5th plus c, and then change this into, we'll get 15. Now I need u, which is going to be x cubed plus 3x squared plus 12 to what power? 5th. 1's up top plus a c. Because it was 1/15th, and it was 1 over u to the 5th, so 1 times 1 is 1. What du went away when we integrated. The integral and du cancel each other out.